In this video, I will explain standard normal distribution and exponential probability. So we start with standard normal distribution. According to standard normal distribution, if you have large amount of data, then most of the time it follows like this type of distribution. So for instance, if you collect large amount of data about ages, height of students in a university, GPA of students in a university, and many other parameters, then if your data is really large, then if it follows this type of distribution, this is called a standard normal distribution. Now in standard normal distribution, this is the formula that we usually use, and that's called z is equal to x minus mu over sigma, where x is the outcome in which we are interested, that's a value in which we are interested, mu is average and sigma is standard deviation, and z is standard deviation here on this line, that how far away you are from the center. So for example, this is plus 1z, 2z and 3z, which mean like 1 standard deviation from the mean, 2 standard deviation and 3 standard deviation, and similarly on the other side. I will explain standard normal distribution through two examples. This example and these two examples. There are some manual parts that require manual calculations. We won't be doing them, we'll only solve them, for which syntax is already available in Microsoft Excel and RStudio. We start with this question. In 2003, the average stock price for companies making up the S&P 500 was $30. So that is the average price, $30. And standard deviation, sigma, is 8.2. Assume stock prices are normally distributed. That gives a useful hint that you don't need to go to any other type of probability. It's a normal distribution probability. What's the probability that a company will have a stock price of at least $40? And x will be at least 40. Please note that this is not 40, this is at least 40, which means 40 and above 40. In Microsoft Excel, these four options are available to deal with standard normal distribution problems. One is norm dist, that's called normal distribution. This option is usually used when we have all the things available, when mean is available, the value of x is available, and standard deviation is also available. Then we use this option. If on the other hand, if you are given a z value and you only need to find probability, then we use this option, that's norm dist. So in this case, our starting point will be z value. We will enter a z value and it will give a probability. Now I will show you here, and that it will automatically give suggestion. For example, norm dist, and then it's giving suggestion that you need to enter value of x and then mean and then standard deviation. So which mean most of the questions they provide these parameters, so we'll use this thing. And in norm norm standard distribution, again we will use it when we have z value and we are interested in probability only. So you see here it asks you that enter z value and cumulative. This is exactly the same thing that we also use manually to find out the value of probability using z value from the tables that are usually given in books as appendix. Then norm dist, norm inverse, norm inv, this is used when you are using probability as an input. Now note that in norm distribution, probability was the outcome, our result was probability, but over here probability will be an input. So for example, norm, and it automatically gives it requires you that enter the value of probability and then mean and standard deviation. And this type of is useful when we want to calculate z-value. So this is like a difference. In the upper one, we entered z-value as an input and output was probability value. But over here it's exactly opposite. We enter probability as an input and it will give z-value as an output. And the last one is norm sinv, that is used when you are looking for the value of z only using probability. So it will only require input of probability to give value of z. And you see here, when I enter this, it gives suggestion that enter the value of probability so that it can generate a value of z. So in this way, norm s inv and norm s dist, they are exactly opposite to each other. In norm s dist, what is input becomes output here, and what's input in norm s inv becomes an output in norm s dist. We can do it manually, but then there is another thing that's more user friendly, and that is if you go to formulas. In formulas, there's insert function, and if you insert function, then these options will appear there. If they don't appear, you can manually type them here and they will appear here. So for example, let's say we click on normal distribution, norm dist, and you see it gives us all those options. So for instance, in this case, our case, x is 40 and mean is 30, standard deviation is 8.2, and cumulative, yes, cumulative. Over here you can write true or 1, it's same. So for example, when I enter 1, it gives me this value 0.88867, or I can also write here true and it still gives the same thing. You can click OK, and that gives this probability. And over here, its interpretation requires. Now, for example, the question is that what's the probability that this stock price will be greater than 40? And what we have done, we have calculated cumulative probability, which mean 40 and less than, which mean all probabilities on the left tail. But the question is asking about the right tail. So what we need to do is that we need to we know that the total probability is always 1, so we will subtract it from 1, and that will give us this probability, that's 11% and 11.13%. For the next part, the question is, what is the probability that a company will have a stock price of no higher than $20, which means the probability that it will stay less than $20. So let's say this is $20, less than 20, and we will again use the same thing, formula, insert function, and norm dist, and then we will enter all those values. Over here now x will become 20, mean is 30, and standard deviation is 8.2. And is it cumulative? Yes, it's cumulative, so I can enter here either 1 or true, and you see it gives 11.13%, and that's the cumulative probability. And in this case, because the question is specifically asking less than 20, which mean on the left tail, and that's exactly what this dialog box provides, so we don't need like any further step. However, so our answer in this case will be, the probability will be 11.13%, and we can also, let me convert this into percentage. However, if our question is that what's the probability that it will be greater than 20, then in that case the question will be talking about the upper tail or the right tail, and in that case we will need to subtract this probability from 1, and that will be our answer. But since the question is only asking about less than 20%, so 11.13%. And the next question is that how high does the stock price have to be to put a company in top 10%? We won't do it here, but I can quickly give you an idea that for this one we will make a bell curve, and in bell curve on extreme right side there will be area that's top 10%, which mean all the other area that will be 90%. Now, in this case, we can see that under the bell curve, at that particular point, the area on the right side is 10%. That's given in the question. That's top 10%, and the area on the left side of that particular point is 90%, and that 90% that reflects probability. So for this one we can find out z value using that probability value, and for this one we can use this norm SINV function, norm SINV function, or we can also go to this one in insert function, and there we click on norm SINV, and it asks for probability. Yeah, it asks for probability, and probability is 0.9, and it gives it I mean, you don't need to click OK. It already gives that z value of 1.28, and you know the formula is z is equal to x minus mu over sigma. Now we have everything here. Z value is available, x we have to find out, mu is available, and sigma is available, and using that we will find out the value of x in that case, and that will give us that what is that value, dollar value, that represents the highest stock level. Similarly, in the next question, that's General Hospital's Patient Account Division has compiled data on the age of accounts receivable. The data collected indicates that the age of accounts follows a normal distribution with mu is 28 and sigma 8 days. What portion of accounts is between 20 and 40 days old? And that's a probability that x is greater than 20 but less than 40. So for this one again, we can go directly to insert function and norm dist function, and there let's enter all values. X20, we will do it in two steps. First we will do with 20, and then we will do it with 40. So let's first start with 40, and then mean is 28 and sigma is 28, and cumulative, yes, it's cumulative. Now to understand this one, the first step is always to make a bell curve, and in this bell curve you note that mean is mean is around 28. One value that's 40 is on the right side of the mean, and the other value that's 20 is on the left side of the mean. So let's say if our center point is 28, 20 will be on the left side and 40 is on the right side, and we have to find that area between 20 and 40. So what we do is that we calculate this thing, cumulative probability with 40. In the next step we'll do with 20, and then we take a difference of these two, and that will give us area between 20 and 40. So when we do with 40, that gives us this 0.9331, and when we do the same thing with 20, that gives us 0.1586, and if we take a difference of that 0.933 value that we saw earlier and this one 0.1586, that will give something close to 73%, which means almost like 77% of accounts they lie between these two values, between 20 and between 40. The next part is that the hospital administrator is interested in sending reminders to the oldest 15% of accounts how many days old should an account be before a reminder letter is sent? Now again, in order to better visualize this problem, just imagine there's a bell curve, and the question is oldest 15%, which means it is talking about the extreme right side of the bell curve. So on the extreme right side of the bell curve, the area will be, will take it 15%, and the area to the left of that point will be 85%. And the question, so we'll be using that 85% area that also represents probability, and we can use it to solve this problem. And because we are dealing with here area that's 85% or probability, and we have to find z value, so we will use norm s inv function, and that will require us probability, and probability is 85, and that already is giving us 1.036 as the value of z. This value 1.036 can be rounded as 1.04, and then we will use the same formula, that's z is equal to x minus mu over sigma, and now we have z value, x we have to determine, mu is given, that is 28, sigma is already given, and then that will give us the value of x that will be close to something $36, so which at 36 days, so which mean that when the hospital administrator he wants to determine what are the oldest 15% account, it means those accounts that are at least 36 days old. So he would send reminders to those accounts that are 36 days old or greater than that. And the next question is that the hospital administrator wants to give a discount to those accounts that pay their balance by the 21st days. What percentage of the account will receive that discount? For this one, again, we can use that function, norm dist function, because we have been provided with all values. We have value of x, that's 21, 21st day, and mean is 28, sigma is 8, and cumulative is 1. And it shows here that 0.1907, which mean around 19% accounts they will qualify for discount. In RStudio, there are two types of functions. One is pnorm and other is qnorm. When we are given all the values of x, mean, and standard deviation, then we use pnorm. And over here, one very good feature is that it requires specifying is it lower tail or upper tail. Now for instance, let's say for this question that we just solved on Excel, uh, this is the value of x, that's 40, that has been asked in the question, and then after that 30 is the average and 8.2 is standard deviation, and the question is asking what's the probability that a company will have a stock price of at least 40, which means 40 and above 40. Now just for sake of demonstration, although this is not an answer to this question, if we use lower tail, this lower tail will give us probability that will be less than 40. So when I run this command, that will be 0.8886 or 80.86, and I can subtract this one from 1, and that will be something 11.13%, and that will be the probability of having a stock price of at least 40, which means 40 and above that. But we don't have to do these manual things, because we can specify here that lower tail is equal to false, because we are not asking about the lower tail. The question is not asking about the left side of the tail. The question is asking greater than 40, which mean on the right side. So which mean we are not talking about the left side, but rather the right side, so we specify here false, and when I run this command it will give me 11.13%, and that's exactly the same probability that we had calculated earlier. Then in the next question, what is the probability that a company will have a stock price of no higher than 20%? Now this is a question that's about left side of the bell curve, or left end, because it's about no higher than 20. So in this case we will use value of x is 20, mean is 30, sigma is 8.2, and lower tail is true, because we are interested in that. And when I run this command it gives this probability, that again gives the probability of 11.13%, and that's actually the right answer for this one. So and the next thing in normal distribution, where we can specify probability to get the z value, that's called as q norm function. The next part of standard normal distribution is q norm in RStudio, and q norm syntax is used when we use probability as input. So for instance, let's say solving this question, how high does a stock price have to be to put a company in the top 10%? And as we discussed earlier, that this top 10% is representing the extreme right side of the bell curve, which mean on the other side, on the left hand side, it's 90% or zero point 0.9. So let's say if we want to calculate z value, that will correspond with this one, and that z value can be used to calculate the probability by using formula z is equal to x minus mu over sigma, and this is q norm, and 0.9, that's 90% probability. And when I run this command it gives a z value of 1.28. And similarly we can also extend by giving more input. So in q norm this is 90% probability, and we can also add there a mean and standard deviation, and whether we are talking about lower tail or not, that's true. And if I run this command, that gives the probability of 40, that gives us the x value of $40, which mean in this case, in this question it says how high does a stock price have to be to put a company in the top 10%. So which means it should be $40.5. If you want to put that in top 10%, it should be at least $40. So this is q norm function. I would like to repeat this RStudio part one more time, that in RStudio when we are dealing with standard normal distribution, there are two syntax. One is p norm and q norm. P norm is used when we have all our variables, value of x is given, mu is given, and sigma is given, and then we can determine whether we are talking about the lower tail or we are talking about the upper tail. And you always start with drawing a bell curve, and using that we can find an answer to the problem. And the other one is q norm. In q norm we can specify, or we can enter probability value as input, and it will give us value of z, or we can we can also add some other inputs. So for instance, this is probability, and then mean, and then a standard deviation, and then lower tail or upper tail, and that will give us the value of x. The last type of probability that we are dealing with is exponential probability. Exponential probability is also about continuous variable. Mostly it's about time, the time it takes to complete a task, and it is usually juxtaposed with Poisson probability. Poisson probability is about like number of occurrences in a particular time period, and this is about how much time it takes for each unit. The formula for exponential probability is this one. Probability that x would be less than a specified number is 1 minus e. A is a constant, minus x sub 0 divided by mu, and mu is average, and that will give the probability that a time will take less than that specified time. If it's about more than that, then we can subtract this whole thing from 1 minus this whole thing, or we can also reduce that to simply e raised to the power x sub 0 over mu. And for this one, there is no separate or dedicated syntax. We just write formula manually, and the formula for this one is the same formula. That's 1 minus e and raised to the power of b3 over b4, where b3 over b3 is x, and b4 is mu, and that gives us exponential probability. Now, for instance, let's say in this question, Sparagorsky and Associated conducted a study of service time at the drive-up windows of fast food restaurants. The average time between placing an order and receiving the order at McDonald's was 2.78 minutes. Okay, so that is the time it takes to fill an order, and this is like continuous variable, and we can say that this is exponential distribution. Waiting times such as these frequently follow an exponential distribution. Okay, that's specified. What is the probability that a customer service is less than 2 minutes? So, okay, less than 2 minutes, x becomes 2 and mu becomes 2.78, and because the question is asking less than that, so which means we will just use the same formula, that's 1 minus exp, and then within parentheses 1, and then raised to power of minus negative b3 over b4, and that gives us 51%. The next part is that what's the probability that a customer service time is more than 5 minutes. So for this one, we can use the same formula, and that will give us, this formula will give us less than 5 minutes, and then we can subtract that from 1. So this is 5x, in this case is 5, and mu remains same, 2.78, and this gives us less than 5%, but because the question is asking about more than, so we subtract that from 1, and that will become 16.55%. And the last part is that what's the probability that a customer service is more than 2.78 minutes. Now again, that's about the right side. So again, first of all, we will do it in two parts. In first part, we will calculate the normal one, and that's a probability of less than 2.78, and in the next part we will subtract it from 1. So 2.78 is x, mu is also 2.78, and that gives us a probability that it will be less than 2.78 is 63%, and this is the probability that it will be more than that. So this is how to do exponential distribution in Microsoft Excel, and the most important thing is that this is the formula, and we are using that formula as such. There is no dedicated syntax for that, as we had seen in standard normal distribution. We can also solve exponential probability problems in RStudio, and the syntax is PEXP, value of x, rate, and then we need to specify, are we talking about lower tail or upper tail. It's a two-step process. In first step, we will take inverse of the time, and that's given, and that's the average time that's given. We will take its inverse, and this one is the value of x in which we are interested, that's usually given in question, and then lower tail or upper tail. Now, I would like to remind you that as I mentioned earlier, that exponential probability is usually juxtaposed with Poisson probability. Now, for example, a Poisson probability was about number of occurrences in a specified interval of time. So, for instance, let's say if we say that there are two customers, they arrive in 1 minute in our driveway, then how much time it takes to serve one customer? It will be 1 over 2. That will be half minute. So half minute for one customer and half minute for another one. So which mean when we talk about like number of occurrences and uh, let's say 2 3, and if we take their inverse, that is the time that it takes to serve each customer. Or let's say if we say that at a McDonald's they can serve 4 customers in 1 minute. Now 4 customers, that's occurrences, number of 4 customers. We're talking about customers. And if the question is that, okay, how much time it takes to serve each customer, we will take inverse of 4, that's 1 over 4, that will be equal to 0.25, which means it takes 0.25 minutes or quarter minute to serve each customer, and 0.25 multiplied by 4 will be equal to 1. And the syntax for exponential probability also involves rate. So this means that we need to take, when we are in this problem, we are usually given time. So for example, less than 2 minutes, less than 5 minutes, and like that. So we need to take inverse. So that's the first step, and in the second step we will use our syntax. So solving the same problem in RStudio, here we have mean time is 2.78, so which means the first step is that we will take inverse of that, 1 over 2.78, and when I run this command, that gives 0.3597. so this is the input that I'll be using in rate. Okay, the first question is that what's the probability that a customer service is less than 2 minutes? Okay, so it is less than 2 minutes, so in PEXP2, and rate is the inverse of that time, 0.3579. Lower tail, yes, lower tail, because it's less than 2 minutes, so we are essentially talking about lower tail, so it will be true. And when I run this command, that gives us a probability of 0.51, and that's pretty much exactly the same probability that we also calculated with Excel. And then the next one is that what's the probability that a customer service time is more than 5 minutes? Now in this one, let's say this is our command, that's 5 minutes, and then rate is same, that's inverse of average time. Lower tail, no, it's not lower tail, because its question is asking more than. So the question is asking about the upper tail or the right tail, so it's not lower tail, so we'll say lower tail, no, it's false. And then when I run this command by pressing Control Enter, that gives 16.55%, and that's exactly the same probability that we also obtained in Excel. And the last one is what is the probability that a customer service is more than 2.78 minutes? So 2.78, that is the time that's given, and then rate, that's the inverse of mean given in the problem. Lower tail, no, because the question is asking more than. So the question is asking about the upper tail, not lower tail, so lower tail will become false. And when I run this command, it gives us probability of 0.3678 or 36.78, and that's exactly the probability that we also obtained in Microsoft Excel. So this is about exponential probability. I would repeat it very quickly. Exponential probability in RStudio, it comprises 2 steps. In the first step, we will take inverse, that's dividing the mean time 1 over mean time, and in the next step using that value as the rate, and also using appropriate either lower tail as true or false, and that will give exponential probability.